All right, this is a video for geometry. We will be looking at characteristics of a rhombus, rectangle, and square. Let's start off with a rhombus. And the way I want to set this one up is by reminding you what a rhombus is and then asking you to pause the video and see if you can investigate or discover on your own any characteristics around diagonals of a rhombus, where they might intersect, and diagonals relating to the vertices. I just noticed a typo that I will correct. Okay, so anything unique happening where the diagonals intersect, and is there anything unique happening at the vertex of the rhombus where the diagonal intersects the vertex? So again, try to pause the video, try this one on your own, and let's see what we can do here. First, I want to remind you of a rhombus. A rhombus is simply an equilateral quadrilateral. Okay, we don't know anything about the angles, but we just know that all four sides are congruent. So let's try intersecting diagonals, see if we notice anything. So I'll draw those in. It looks to me that they're perpendicular, and maybe there's something else you're noticing as well. They're also perpendicular bisectors of each other. Okay, so they intersect at the midpoint, and we knew that because it's a parallelogram, and in a prior video I showed you that parallelogram diagonals bisect each other. But here, even more specific, they intersect at a right angle. So diagonals of a rhombus are perpendicular bisectors of each other. Okay, let's think about what's going on at the vertices. I'll keep these diagonals drawn in as purple, but I'll draw some things regarding angles in blue here. So see if you can notice anything about these angles at the vertices. What's going to happen, what's true, is that those angles will be congruent. So the diagonals are angle bisectors. And we also know that because this is a parallelogram as well, we know that the opposite angles are congruent. So just in this region right here, we've created 4 congruent angles. So that could be useful for sure. Okay, let's do an example with this one, and then we'll do some theorems around rectangles. So let's find some angles, and let me make this a little bit larger here. So first off, we know that diagonals create perpendicular bisectors, so we have a right angle right in the middle. And I'm going to work with this little triangle right here. It's a right triangle. We have a 58-degree angle, we have a 90-degree angle, and then we have a missing angle. So I'll call that X. So X plus 58 plus 90 equals 180. Let's solve for X there. So X is 32. Let's draw that in. And now there's a lot we can do here. And so let's start compiling. We need to find angles 1, 2, 3, and 4. Hopefully you can tell that 1's a 90-degree angle because of those perpendicular bisectors. Hopefully you can tell that 2 and 3 have to be the same because diagonal BD is an angle bisector. And since opposite angles of a parallelogram are congruent, we know that angle D has to be the same as angle B here. So therefore 2 and 3 will both be 58 degrees. And lastly, angle 4 looks like it would be 32 degrees. Okay, because diagonal AC is an angle bisector, and it would have to create an angle that's congruent to the 32. All right, moving on, let's look at what happens when we have a rectangle. And again, I encourage you to pause the video and see if you can discover anything around the length of diagonals in a rectangle. This one is a little bit more intuitive, but just as a reminder of what a rectangle is, it's simply a quadrilateral with 4 congruent angles, which would have to be right angles. So let's draw the diagonals. What do we think might be true about those diagonals? We already know they bisect each other because it's a parallelogram, but even better, they are congruent. Okay, so those angles are congruent, and since they do bisect each other, we can even say that they create 4 smaller congruent segments as well. But those diagonals are congruent. So as our example here, last example for this video, if we have diagonal SF is equal to 2x plus 15, and then diagonal RB is equal to 5x minus 12, and we are given that this is a rectangle, as you can see from the right angles being denoted. Let's find what x is, and let's find the length of each diagonal. So we can say that 2x plus 15 is equal to 5x minus 12. Let's add 12 to both sides, plus 2x plus 27 is equal to 5x. And let's subtract 2x from both sides. And lastly, we'll divide by 3. So x is 9. And let's find the length of one of the diagonals. They're congruent, so if we find one, we're going to find the other as well. SF is 2x plus 15, so 2 times 9 plus 15. That is 33. Okay, so we found x and we found the length of the diagonals. Just as a quick closure piece here, I mentioned at the very top that we'd be working with squares as well. And I didn't really bring up squares. But just keep in mind that squares are particular examples of both rhombuses, rhombi, and rectangles. So any of these characteristics that apply to either a rhombus or a rectangle would also apply to squares as well.